Hello class, today we are looking at the exterior angle theorem for a triangle. So the essential question is, how do I find the exterior angle measures of a triangle? Your learning intention. I am learning to find missing angle measures in triangles. So for your warm-up, this comes from our last set of notes. Find all the triangle measures. So what do we know about a triangle and its interior angle measures? Pause the video and see if you can complete it on your own. If you remember correctly, the sum of the interior angles of a triangle add up to 180 degrees. So 180 degrees is equal to 90 degrees for our right angle there, plus 71x minus 1 plus 20x. There's my equation, and now we use algebra to solve. 180 degrees is equal to 90 minus 1 is 89 degrees, plus 71 plus 20 is 91x. 71x plus 21x is 91x. Now it becomes a matter for algebra. Step 1. Subtract 89 from both sides. Make sure you've got your calculator so you can do that. What is 180 minus 89? It is 91. 91 degrees is equal to 91 times x. Well, this one's simple enough, we know. The only number I can multiply 91 by and get itself back is 1. So 1 degree is equal to x. Now, as I'm looking at this, I've got to substitute in to find these two. This one is definitely the easiest. This will be 20 times 1, and this is 20 degrees. Okay, this is 90. That means these two are 90. If this one's 20, then this one has to be 70 degrees. Whenever you have a right angle or a right triangle, you know that the acute angles will have to add up to 90 degrees also. And that takes us to our theorem. The measure of the exterior angle of a triangle is equal to the sum of its two. Here's your exterior. These are the two that we are talking about. Here's your exterior. These are the two we're talking about. They're called the remote interior angles. So, A plus B will give you this measure of this angle. So we're going to prove it. It's a quick, easy proof. We want you to get started thinking about how to write them. So you're given triangle ABC with exterior angle BCD. What we want to prove or want to show is the measure of angle BCD is equal to the measure of angle A plus the measure of angle B. Let's get started. Okay, 99% of the time you start with the what? Given information. We've got triangle ABC with exterior angle BCD. Okay, I can say that because it's stated right here. That is what we're given. That is what we start with. Okay, now I've got two things I look at. First, I look at this first statement. Triangle ABC. Okay, I've got a triangle. What do I know about a triangle? The sum of its interior angles adds up to 180 degrees. So I've got a triangle and I'm going to use that information. The measure of angle A plus the measure of angle B plus the measure of angle BCA equals 180 degrees. Why? Triangle sum theorem. Okay, now I've used my given, I've looked at my triangle, I've used that information. What other figure, geometric figure, do you see up here? If I only had the triangle, it would end here. What would I call this? Well, I would call it a line or a line segment. What do we know? If I'm looking at the line, that line is made up of these two angles. So what do we know about those two angles? They are a linear pair. If they're a linear pair, their sum of their measures is 180 degrees. So I've got that linear pair. I know linear pairs are supplementary. So the measure of angle BCA plus the measure of angle BCD is also equal to 180 degrees. Okay, now I have used everything I'm seeing and everything that I'm given. I've used all that up. So now I have to look at what I've written and see where my similarities are. What do I see on two different statements that is the same? Well, if you say equal to 180 and equal to 180, you are correct. If they are both equal to 180, then we know that those measures are congruent and they have to be equal to each other. So this is going to be by substitution. The measure of angle A plus the measure of angle B plus the measure of angle BCA is equal to the measure of angle BCA plus the measure of angle BCD. Okay, I've set up my equalities. They're both equal to 180, so they have to be equal to each other. Okay, I look again. I've got angle A, the measure of angle A, the measure of angle B, the measure of angle BCA. I start again with the measure of the measure of angle BCA. An angle measure is a number. If I have the same number on the opposite sides of my equal sign, how do I remove it? If I have that same number on opposite sides of my equal sign, how do I remove it? How do I remove a number? I subtract it. So we're going to use subtraction next. The measure of angle A plus the measure of angle B is equal to the measure of angle BCD. This is what I wanted to prove. I've just proved it. These are flipped around, but that's okay. They're still equal to each other. Okay, to tell my reader I am done, I am finished. I do my infinity sign, and that says I have just shown you that that is correct. So if you're still struggling, back up the video and watch the first part again. Now we're going to apply this rule. As we're looking at this rule, we have to remember we're looking for the remote interior angles. The remote interior angles are the ones that are as far away as they can get. So here's my exterior angle. Here's my two remote interior angles. So we don't use the 75. Let's set it up. I know that 75 degrees plus 30 degrees will be equal to n degrees. This plus this is equal to what's on the outside. When I add it together, 105 degrees is equal to n degrees. You can always find that third angle and then subtract from 180. But that takes more work. Okay, so let's look at the next one. My remote interior angles are here. So I set up my equation. 7x plus 5 plus 60 degrees is equal to 20x. Any questions? These two added together make my exterior angle. Okay, 7x plus 65 degrees is equal to 20x. Combining like terms. Now comes my algebra. I have to subtract 7x from both sides. 65 degrees is equal to 20 minus 7 is 13. So that's 13x. Divide both sides by 13. I'll give you a minute while you divide it with your calculator. What is 65 divided by 13? Well, I hope you got 5 because 5 degrees is the correct answer. 5 is equal to x. That looks more like an S than a 5. So there we go, that looks better. So as I'm looking, this one is definitely the easiest one to find because when I substitute it in, I will have 20 times 5, and that will give me 100. No, it will give me 80. No, it does give me 100. I was right the first time. 100 degrees. So if this is 100 degrees, this makes a line. This has to be 80 degrees. Okay, now I can either substitute in or I can use the triangle sum theorem. 60 degrees plus 80 degrees is 140 degrees. 180 minus 140 will give me 40 degrees. The other way would be 7x plus 5, which is 7 times 5 plus 5, which also gives me 40 degrees. Okay, I hope you were able to follow along and actually get the answer before I did. That means you're starting to understand. Remember, geometry is about position and relationships. The one outside is equal to the sum of the two that are the furthest from it. Okay, can you pause the video and do the last problem on your own? Well, I hope you tried. This plus this, these are your two remote interior angles. 77 plus x. 77 degrees plus x degrees is equal to 146 degrees. Subtract 77 from both sides. X degrees is equal to 69 degrees. Is that the only way I could have done it? No. I could have used the fact that I've got a linear pair here. (180 degrees minus 146 degrees. And I would get 34 degrees. So I know this one is 34 degrees. Now I do the same thing again, but I've got two of my three angles. 180 degrees minus 77 degrees minus 34 degrees. Put that in the calculator. What do you get? 69 degrees is correct. Either way you do it. I couldn't remember this for the longest of times, but I could always do this. So there's more than one way to find the correct answer. The way you're going to do it is the one that makes sense to you. I know I'm successful when I can find the missing measures of any of the angles of a triangle. Now, we are all still using the sum of the interior angles. Is equal to 180 degrees. We will use that till the end of the school year. The other thing we're now using is the exterior angle theorem. That's where these two remote, when you add them together, will equal your one on the outside. So if you're still struggling, come talk to me and we will see what we can help you with.